All right, welcome back for another deep dive. This time, we're taking a closer look at random forests. We had a ton of requests to unpack these powerful tools. We've got a whole stack of research here on how they work, their advantages, real-world applications, the whole 9 yards.
Sounds good.
So, are you ready to jump in?
Yeah, let's dive in.
Okay, so, full disclosure. My brain, it kind of works best with analogies.
Okay.
Is there like a way we can explain this whole random forest idea without, getting too technical right off the bat?
Definitely, yeah. I think a good way to think about it is imagine you're facing like a really complex decision.
Okay.
And instead of just asking one expert, you've got a whole room full of them,
Right.
each with their own, unique perspective and expertise.
I like that.
That's kind of the magic behind random forests. They bring together all these predictions from multiple decision trees, each one trained on a slightly different subset of your data, to give you a much more accurate and robust outcome.
Okay, so it's like getting a second opinion, or a third, or even a 100th opinion.
What?
But from, like, really smart decision-making trees.
Yeah, exactly.
Okay.
And just like having a bunch of different opinions can help you make better decisions in real life.
Right.
Having multiple decision trees can actually help reduce bias and improve the overall accuracy in machine learning.
This is making a lot more sense already. But why would you go with a whole forest over, like, just using one decision tree? What makes random forests so special?
They really shine when you're dealing with complex data, where, accuracy is really, really important,
Okay.
especially if you've got tons of features to consider. Think about your work with customer segmentation.
Right.
You're trying to predict, like, which customers are likely to leave based on all sorts of things. Demographics, their behavior, past purchases. It's a lot to handle.
It is a lot of information to process.
Random forests are great at handling that kind of complexity
Yeah.
and making, really reliable predictions.
Wow. Okay, I'm starting to see the potential here. But how do all these different trees work together to make a decision? It just seems like it could get chaotic.
Yeah, it does seem like that, but it's actually pretty organized. There are two really clever techniques involved: bagging and random feature selection.
Okay.
So first, let's break down bagging, which is short for bootstrap aggregating.
Bootstrap aggregating, all right.
It's like taking your data set and creating multiple bags of data from it by randomly sampling with replacement.
So each bag is slightly different.
Yeah,
Okay.
exactly.
Wow.
And each bag is used to train a separate decision tree. It's kind of like having multiple teams working on different pieces of a puzzle, but using slightly different sets of pieces, if that makes sense.
So each tree gets a slightly different perspective on the data.
Precisely.
That's neat.
And then we have random feature selection. At each point where the tree has to make a decision, it only considers a random subset of features. This keeps the trees from becoming too similar and makes sure they're capturing different aspects of the data.
So not only are they trained on slightly different data,
Right?
they're looking at different features within that data.
Yeah. Exactly, yeah. It's like each of those experts in that room is focusing on a different aspect of the problem. This randomness is where random forests get their name,
Okay.
and it's a big part of what makes them so robust.
So by combining these techniques, random forests have some serious advantages over single decision trees.
For sure, yeah.
Like
Well, one major advantage is that it helps to reduce overfitting.
overfitting, what's that?
Overfitting is basically when a model learns the training data too well.
Go.
Like it's memorizing the answers instead of really understanding the material.
Gotcha.
A single decision tree, especially a complex one, can get so focused on the training data that it doesn't generalize well to new unseen data.
So it's like that student who aces the practice test,
Right.
but then completely bombs the real one.
Exactly. But with a random forest, since each tree is trained on a different subset and only considers a random subset of features, they're much less likely to fall into that memorization trap. They actually learn the underlying patterns more effectively, and they can make better predictions on new data.
Random forests sound amazing, but are they like a magic bullet? Are there any scenarios where you might choose a different approach?
Well, no model is perfect, right?
Right.
Random forests do have some limitations.
Okay.
They can be computationally expensive, especially with huge data sets.
That makes sense.
If you need real-time predictions, a simpler model might be better.
Right. Speed is key sometimes.
Exactly. And another thing to consider is interpretability.
Okay.
If you need to understand why a certain prediction was made, random forests can be a bit of a black box.
How so?
They're combining predictions from so many trees. It can be hard to trace the exact reasoning behind a decision. So in cases where transparency is really important, a single decision tree might be a better option.
Okay, that's good to know. It's all about picking the right tool for the job, I guess.
Exactly.
So let's go back to that customer segmentation example. How could a company use a random forest to predict customer churn?
Okay, so imagine a company has a ton of data on their customers. Demographics, purchase history, website activity, all that stuff.
Sounds familiar.
Right, they feed all this data into a random forest model. Each tree in the forest might focus on a different aspect of that data. Some trees might be looking at demographics, others might be focusing on buying patterns, and so on. By combining their predictions, the random forest can paint a much clearer picture of who's at risk of churning.
Than any single factor could.
Yeah,
That's pretty insightful.
it is. It's amazing how this can uncover hidden patterns, and that's just one example. Random forests are super versatile. They're being used in all kinds of applications.
Such as?
Fraud detection, medical diagnosis, predicting stock prices, identifying spam.
That's pretty impressive.
It is.
It's amazing how powerful they are on their own. But what if we could combine them with other machine learning techniques? What kind of problems could we solve then? That's something to think about for sure.
Yeah, it's really exciting.
Well, thanks for diving deep with us today.
My pleasure.
This was a great discussion. I think we all learned a lot about random forests.
I hope.
Until next time, keep exploring the fascinating world of AI. We'll see you on our next deep dive.